Thank you, Henrik. Thank you all for coming. Most of the case studies sessions are on how people are using Puppet, making their environment awesome. I've got this one to give you guys sort of the behind-the-scenes look at how we actually put that together. And yeah. So as Henrik said, I'm a QA engineer. I am responsible for the Puppet Enterprise testing pipeline. So from GitHub through all our various stages of testing and packaging and validation into the final product that goes out the door to you guys. So I'm going to talk first about how we actually build Puppet Enterprise, what goes into it, and what the challenges are around testing it. I'll give a quick overview of continuous integration and why it's important. I'll then cover what the actual shipping and testing process is when we make a change to Puppet Enterprise, how we get that out the door. And then I'll go over my plans for the future and how we're hoping to improve the process and keep streamlining it. So Puppet Enterprise is big. It's really, really, really big. It's not just Puppet and the console and the various things that make that up. It's also Ruby, Apache, Java, all the things that we build so that Puppet Enterprise is on a stable, secure, known platform. And we need to validate that platform across every OS that we support Puppet Enterprise on. And then we need to validate the code and applications on that platform on every OS that we support Puppet Enterprise on. It is a huge testing matrix. So continuous integration is, at the high level, it is bringing all the parts of your application together as often as possible to make sure they all still work together. With Puppet Enterprise, as I was saying, having all these various components, this is actually hugely important. Our biggest issues during testing are not code correctness issues, they are integration issues. They are config files that are not laid down properly, changes in APIs that weren't propagated to all the applications, things like that. So that consistent testing of the entire stack that consistent testing of the entire stack in a known environment is really what lets us deliver Puppet Enterprise as well as we do. All right, now we can actually get to the meat of this, now that the short intro stuff is over. I will cover really everything involved in the process here. The tools and technologies, both the ones that we use from other people, as well as what we have built in-house. The sort of tests that we run at various stages. And finally, I'll put that all together and kind of walk through what happens to a piece of code from when a developer pushes it to GitHub through to when Puppet Enterprise goes out the door. So tooling. We use GitHub for our source control management. They're awesome. We love them. We also use Jenkins for our continuous integration job server. Jenkins allows us to run all of the testing and packaging jobs for all of our components as they need to be run based on various trigger conditions, which I'll cover when I get into a bit more of how the pipeline is put together. It also allows us to handle the large, what we call matrix jobs, which is when you have multiple versions of an operating system and multiple operating system distributions, it creates a matrix of job possibilities. And Jenkins handles those really well and gives us great feedback on whether a problem is widespread or focused on a specific platform. VMware, of course, is our virtualization platform. We treat all of our test environments are disposable. So we spin those up on demand in VMware. About 200 to 500 virtual machines at a time for our full test matrix across all of our supported platforms. Most tests are a smaller number, and we have tried that with other cloud providers and had huge reliability issues. So having it in-house on a virtualization platform has been a huge benefit for us in making sure that our tests run reliably and don't create too much noise from infrastructure issues. And then Sauce Labs is a provider of web UI testing services online. We use them for our Puppet Enterprise console UI testing and that, again, for us to build in-house what they have would be a huge undertaking. Spinning up VMs for not just the operating systems that we support Puppet Enterprise on, but really all the operating systems that people might use the console on, which actually comes up to be a wider number. It includes desktop versions of Windows, which we actually really only ship Puppet Enterprise for server Windows. And of course, the huge number and version of web browsers that everybody uses. And for us to spin up the VMs to be able to test that ourselves would be a huge, huge undertaking. And their APIs and their services let us hand that off to someone who knows what they're doing. So as I was just saying, we do have a ton of automated UI testing in Puppet Enterprise. It is still one of our least reliable sorts of test, and that's something we're working hard to improve because it is very, very useful to get that feedback of user workflows and knowing that those workflows function the way they're intended. But just due to the nature of web browsers, running that automation does run into timing issues. Unit tests are unit tests. They haven't changed in 40, 50 years. We run our JavaScript unit tests both in real browsers as part of the UI testing, as well as in a emulated JavaScript environment called Phantom.js, which is basically a headless implementation of JavaScript as it exists in a browser, which allows us to run those without needing to spin up the full browser environment, spin up the full Puppet Enterprise stack to serve the web page. We can actually just load the JavaScript and test it and get much more rapid feedback to the development team. Every component of Puppet Enterprise has system-level tests as well. So that is things like Puppet Core, mCollective, as well as even some of the parts of the console that provide APIs have tests that run at below the UI layer to validate those APIs and their integration. And then we have a suite of tests that make sure everything works together at the high level, so that when you, say, click the run Puppet in live management, we have tests that validate live management sends the right message to mCollective, and that mCollective sends the right message across the network. And then from across the network, Puppet gets kicked off the right way. So we'll walk through live management. I picked a product at random, but from when the developer pushes a new piece of code to GitHub to when that would go out the door, I'm going to walk through the process as it exists now. And yeah, so Jenkins is always polling GitHub. We have jobs for every single repository involved in Puppet Enterprise that just watch to see if there is new code. And as soon as there's new code, we pull it down and run the unit tests. For an application like live management that is a web application, that means we run both the Ruby JavaScripts for the server side, or the Ruby unit tests for the server side, as well as the JavaScript unit tests for the client side. Once those pass, assuming they pass, packages get automatically built and pushed to an archive server. So we have packages of the latest version of the code for all of the components at all times. At the moment, deciding which version of those packages to put into Puppet Enterprise is still a manual process. So as development happens, a human being will eventually say, okay, it's time to pull this together. They'll sign the packages that we decide we want to ship, put them in place, and push the big red button, and Puppet Enterprise gets built. This is a stage that we're looking at more automation around. At the moment, the biggest challenge to that is the package signing and figuring out our chains of trust. And if we have fully automated signing of packages, kind of how that impacts the security of our signing process. But once that tarball is built, the fun begins. So from the big red button, Puppet Enterprise is built across all of our supported platforms. Automatic testing gets run. This spins up VMs, installs Puppet Enterprise, and does some basic functionality checks to make sure that that is actually a sane composition of the PE ecosystem. From there, we run all of our UI tests in Sauce Labs, as well as the system tests in our internal VMware infrastructure for all the backend services. And once all of those are validated and we know that each component is functional, we run the integration suite, which, as I was saying earlier, validates that everything can talk to everything else correctly. So this is where I get to ramble for a little bit. The big thing that we want to fix is automation around the various stages of testing and how those are put together. We have a number of small chunks that are fully automated. Code gets pushed, unit tests get run, that works awesome. Someone pushes the big red button for PE, some basic smoke tests get run, that's awesome. But filling in the blanks, being able to say someone pushes code, unit tests get run, that package can be put into a full PE stack, have the smoke tests get run all the time, is where we want to be. Part of that is what I was saying earlier, the chain of trust around our signing keys and making sure we understand the path code will take when we build that. Part of it is just the sheer scale of running those Puppet Enterprise integration tests all the time is huge. Like I was saying, for our full matrix, this is 500 VMs that we need to spin up. And those tests definitely take longer than the average time between pull requests in our repositories. So that means we need to be able to run more of those in parallel in order for the testing to keep up with the development team. The other thing we really want to work on is being able to test more of the PE components before they're put into the final Puppet Enterprise form. When we have to rebuild that entire package before we can run the per application tests, that causes quite a bit of the hassle because that packaging step is pretty slow. And what we want to be able to do is say after the individual component has its package built, unit tests pass, RPM gets built, we want a way to validate that RPM without needing the full weight of the Puppet Enterprise environment, and for each component being able to say which parts of Puppet Enterprise need to be there so that we have the trust that we have created an environment that looks like Puppet Enterprise and that we can trust the results of those tests later is really important, and is why we still have not moved those tests earlier in the testing process, because we need to know that everything works right in Puppet Enterprise. And really just being able to do things faster, more parallelism, more hardware. Our testing environment is bigger than the rest of the Puppet Labs infrastructure put together, and it is still never big enough. So I'm a little earlier than I wanted to be, but if anyone has any questions, I'm happy to take them. Can you just queue up at the mic so it can get on the recording?
Hey, I just wanted to know how deep you're testing each supported resource, or what your tests actually are doing on the system level, and particularly how that compares to what open source is doing. I hope they're similar, but...
So for the components that have both PE and open source versions, like Factor, like Puppet, we actually have internal forks of those repositories that just have PE patches, and we merge open source in regularly. So those PE repositories follow the same testing path, and we actually run all the same tests that are in the open source Puppet code. So we test every resource in depth on all the supported platforms, in as much as the tests actually do that. I'm personally not super familiar with the individual test suites. I'm mostly at the sort of higher automation level of the testing. Does that?
Yeah, thank you. That answers the question. I also don't think the unit level of functional tests that are in open source are exhaustive either.
Yeah.
At least you follow the same.
I was wondering if you could go into a little bit more detail about how you, as the testing organization, separate from the developers, decide what your testing suite is going to be. Presumably, they're testing a unit level. They have internal knowledge of things that maybe your group shouldn't have. What kind of process do you have to make sure that you're covering everything you need to, versus what they did?
So we do. Everyone's familiar with DevOps. We try to do Dev QA. Our team sits right next to the developers. There are some days I spend more time talking to the development team than to other people in QA. We have a number of people on the QA team that work closely with product to develop the high-level functional tests for whether the product is doing what it's supposed to do. And we work pretty closely with the development team on the system-level integration tests to make sure that the components talk to each other and that the release team that manages packaging and integration and the development team and the QA team are all on the same page there. Unit tests are owned pretty much exclusively by the development team. We're pretty hands-off. We basically provide a service for those to get run. Was that?
Yeah.
All right.
How much do you test like manifest compatibility versus just the basic data? Because manifest obviously are different and there are edge cases all over. So what do you do about those?
Again, I'm not super familiar with the individual tests. I mostly do the automation. I know there are some manifest tests in the Puppet repository along with all the other tests, but I'm not sure how deep they get into that and what they do exactly. I'm happy to look it up and sit down with you later if you really want to get into it. Yeah, I'm sorry I don't have an answer right now.
So my question has to do with load testing or stress testing. What do you guys use for that if you do it, and how extensive or how much do you stress the system?
Yeah. So the load testing we actually still do in EC2 rather than in our internal VMware environment, just because of the sheer number of machines that we need to do that. Our load testing when we ship a new version of PE is still it's a fairly hands-on process. We spin up a big master in EC2, and then we just keep adding nodes 10, 20, 30 at a time until it starts to fall over. We validate that mcollective can still function, that we don't get catalog compile timeouts. Those are the two big load impacted features. We do also have automated performance testing, which runs internally more often. I think we run those about once a week that will hit the master with compiling various complicated catalogs and just track compilation time and stuff like that as well. But the stress testing is very much someone sits down and tries to break it process right now. We are looking at how to automate that, but because with the stress testing, you're looking for it to fail, it's much easier to validate that something is working in an expected way than that something is failing in an expected way. So was that what you were looking for?
With all this stress testing going on, are we going to see some numbers coming out other than 1,000? Because that's the answer for everything is it handles 1,000 nodes. Especially if you're doing EC2 and you're actually ramping it up until you find where the breakpoints are, it would be nice to actually have some transparency in this data maybe.
I do not disagree with you. I would love to have more of our scale testing and performance testing metrics and how we got those numbers public. Unfortunately,
I understand everything can't be public. We know how that goes. But
and it's one of those things where realistically, marketing owns that, and marketing needs our message to be competitive with everybody else's message. And when you start getting into more of the gritty details with the numbers, one of our competitors is going to go in there and dig that apart and say, look at this case where Puppet's terrible. And
do you know where the marketing guy is that I can tell that 1,000 isn't very competitive to? I mean, even a 3x3 matrix, right? Maybe it's just some templates of here's small deployment, big deployment, and how much it can handle or something.
We're definitely working on getting better numbers, and we are working with the marketing team to try to get better stuff out. It's a slow process. It all has to be vetted through entirely too many people to make sure that.
Well, that is in the ad copy, but you also have the Puppet scaling guide that goes out to people who are potentially buying the product or have bought the product, and it'd be nice to maybe see it in there. If you can sneak it in.
For the scaling guide, the authors of that are around here. Eric Chameau and Lauren Rother are both at the conference.
Thanks.
Yeah.
So you just told that for stress testing, you just launches a lot of nodes. You can do catalog compilation. You can just issue catalog compilation on the Puppet master itself. Do you use that to test how many catalog compilation it can handle at a time?
Yeah, we do have, that's part of our automated performance stuff that runs once a week. It's a little bit different from the stress testing. The stress testing, we're looking for the breaking point. The automated stuff, we're kind of looking for real useful numbers. I think right now our numbers just get compilation time and we don't instrument the parallelism as well as we should. It's definitely something we can look into.
And how big is the test team compared to dev team?
So our dev team is 20-odd people at this point, and the testing team, we're up to, how big are we now, Scott? 8, 10, something like that. But I guess including the open source team, development is closer to 30 or 40 now, and we're at about 8 to 10. So we're about a quarter to a fifth of the size of dev right now.
Okay, and last question. Can you name some of the tools which you use in automation, like any commercial tool or open source tools? Like, what are the tools, actual name of the tools which you use for your automation?
Yeah, so most of it is hand-rolled shell scripts that live inside Jenkins. Jenkins is our big job runner, like I mentioned earlier. We have the Puppet acceptance tool, which I think we recently renamed Beaker, which is an open source project on GitHub. That is what we use to spin up our virtual machines and has our homegrown DSL for the system level testing. And that's available for people to poke at. We also have the Puppet Labs packaging project by our release engineering team, which is what we use to be able to build RPMs and Debs and Solaris packages and OS 10 packages and Windows MSIs and all these other things for our products and have them be fairly consistent across all those platforms. And that is also an open source project. But all the glue that kind of wires everything together and does the automation is all in-house, and really we did hack most of it together with Bash.
So of the 500 machines that we're spinning up, how many of those are upgrades, out of curiosity? Now that we have more and more versions out.
We test on upgrades from the latest, how do I want to say this? This would be easier if I had a picture or a slide for it. So we test the latest point release of all the minor releases of all the supported versions of PE on the upgrade matrix, which means that, for example, when we released a new version of PE 2.8 last week, I think it was, when it finally went out the door, we validate that across the latest 2.0x, the latest 2.5x, the latest 2.6x, the latest 2.7x, as well as 2.8.0, 2.8.1, 2.8.2. No longer against 1.2 because 1.2 is no longer supported. For PE3, the only supported upgrade path is from 2.8. So for 3.0.0, we validated, well, we didn't have upgrades in 3.0.0. So when we did 3.0.1 that had upgrades, we just tested the upgrade from 3.0.0 and from 2.8.2 and 2.8.3. Is that? Yep. And those upgrade scenarios come down from product of what the supported upgrade paths for customers are. Yeah. Yep. Is there anything else? All right. Well, we got started late, but I think I can still let you go on time. Thank you all for being here. I'll be around if anyone's interested in testing and wants to just chat more.